Hello, this is a note about two things. It's a ASCAT winds, the most important data we have underway in the ocean or coastal waters, and also qtVlm. And qtVlm has a new update to their georeferenced image display options, which allows us to now download pre-configured images and they'll be automatically georeferenced. And in particular, the ones we're going to look at is the graphic versions of the ASCAT data. And ASCAT is satellite wind measurements. These are a European product. There's two satellites that we look at, and the reference. And I'm going to show briefly how it works, and then refer you to this article, this resource, starpath.com/ASCAT. That's in lowercase ASCAT. And so here's this article, and it tells about the satellites and where you can read about it. We have a big section in our textbook about it, but this is what the graphic data looks like, a picture like that, and that's what we're going to use. Here's a ton of references on special factors. These are the kind of images we're going to download, and they are this size. Let's see, 2, 4, 6, 8, 10. I think it's 10 by 15 degrees of longitude. They're going to look like this. And these, I want to stress, are real measurements, real satellite measurements of the wind speed. It's not like a model or an estimate or a forecast. This is what it really was. And the time, like for example, this particular picture of Hawaii, this was at 1931. This satellite went by here 1931. September 26. It doesn't even, oh no, 2012. We've had this up, we've been preaching the value of ASCAT for a long time. However, and over all these years, I've been trying to figure out a way that makes it, since it's so important, since the data is so important, I've been all these years, it looks like from 2012 or something, always trying to figure out some way to present this data to mariners underway so that it is useful, and you can take it into account in your routing and in your actual navigation about what's ahead. And we finally figured that out maybe into last year, this year sometime. We figured out a new method, and that's a method we're going to use, and I'm going to show you, and that's described up here, and it's tied to these indexes that look like this. And we've defined these areas. These are our definitions of the areas. This San Francisco. Now, here's the point about this graphic index. When you're going to get data in this area, if you're sailing in this area, you're going to get data twice a day. Sometime, you're going to get data twice a day, plus or minus an hour of these times. Actually, these times are probably more accurate than an hour. They're probably accurate within half an hour. But this is the Greenwich mean, the universal time that a satellite has gone by here. There are two satellites. Metop B and Metop C, and they're going up this way, ascending, and then they're descending, going down the Earth that way. And so you have two passes that way from each satellite. So there's 4 opportunities for data. But what I want to show is now, this is the time you're going to compare. Like this would be a perfect comparison to an 18 Zulu surface analysis, if you're comparing to a surface analysis, and this would be roughly like a 6 Zulu surface analysis. And the latency is about the same. In fact, you'll get this data a little bit quicker. The ASCAT data latency is about 2 hours. So even though this satellite went by here at something like one of the satellites went by here, up or down, at 5:35, you won't get that. You won't be able to see that data until like 7:35. A couple hours later is when you look. But if you go in here and you're actually navigating and you have alarm set in your nav station and you have alarm set to go here, look at this area at 7:35 UTC, 7:35 UTC. Now, that's going to be the middle of the night in the summer here, but anyway, that's UTC. And in this case, it's 20:25. You set your alarm at 2025 UTC to get up and go get this data. And what you have to download is you have to download 4 images. You have to download 4 images, and that's what I'm going to illustrate. And it's all done now automatically, or well, let's call it semi-automatically. But this graph here, this graphical index with the times and the names and so forth, that's the key. Now, let me just illustrate real quickly the tricky, why this is a little bit, why this data has not been used very much, but now it can be. It's a complex process, because I mean a complex data source, because here is one pass of the satellite, and it's got data. It cannot take data right underneath. There's what they call a nadir gap. There's this gap right underneath this satellite right here. There's no data. So this is data and this is data. So when a satellite goes by one of these little cubes here, you don't know what you're getting. You could be getting this right-hand starboard side or the port side of this, or here you could be getting the port side of this satellite C descending, oh no, this C ascending going up, and this is ascending going up, and these are the descending. So that's the complexity, and you read this article and you'll see how you identify. Well, it doesn't matter. Frankly, it doesn't matter what these are. You can read about this to understand how it works, but it doesn't matter. You're going to get the data if you just follow this prescription. This is then a comparable European version. The other thing I'd recommend is go in here and watch this video that says, we made a set of these. I'm going to show very quickly. We made a set of these that not only work in qtVlm, but another set that works in Google Earth. And I'm going to illustrate this too, because it's not that if you have Starlink on your boat, there's no reason you can't use Google Earth for all kinds of things underway, and other internet resources. But right now it's just showing that. So that's the main thing. And again, this is a detailed article. This shows the area, what's the range from underneath the satellite to where you get the data and so forth. But again, the important thing is none of that matters. Okay, so let me go now to, let's just take a quick look at the Google Earth. That's worth doing, Google Earth. And then let me look at North America. And that just turned on everything. Let me shut off the index. Well, first of all, just turn on the index. So that's the index viewed on Google Earth. And then, you just load all this into Google Earth and click one button, and that's explained in that article. So let me just turn them all on and shut the index off. So now you're looking at the satellite passes. And again, remember, this is live data. This is not live, but it's the most recent. It's the most recent. And again, if you look at the right time, it won't be any older than 2 hours. If you look sometime, you could look, and it's 8 hours later, depending on when you look at the data. So anyway, that's the way it looks on Google Earth. And then if you wanted to, you can shut those off, and then just choose, just open up one of these, and then you just look at like B descending. Has that got any data in it? Yeah, and you can zoom in there and read that and so on. So that's Google Earth. That's not my subject now. Now we want to talk about qtVlm. And that's in their new feature. It's under Gribs, Weather Images, Open a Weather Image. Or on a PC, no, I'm on a Mac. So this is Option W. On a Mac, it'd be Alt W. So you open that, and that's this. And then if you want to download one of those, there's 2 ways you can do this. Now, if you're starting from scratch, you could go in here and click this synopsis, go to North America, go to download, and then here you can get the index. Here you can download the index, or here you could download any one of these. I'm going to be looking at. I'm going to be looking at San Francisco, I think. Yeah, San Francisco, so forth. So you do that. Well, okay, wait a minute. Hang on just a minute. I'm going to come down here. I've got these loaded already. I don't want to mess that up. So let me go to number 8. there's eight places you can store data, but you can overwrite it and write it and so forth. So so I'm just going to demonstrate this by going to number 8. And then I'm going to go ASCAT North America download. And then I'm going to go up here, say, to San Francisco. These are alphabetical. San Francisco. And there's 4 passes. This is ASCAT B ascending. That's where we usually start. You go there, and then that loaded it, and then you can come in here and say, okay, and that's going to load that. Well, somehow after all that talking, I clicked the wrong button. I did not load. I don't think this is San Francisco. San Francisco should be up here. I don't know which one I loaded. But it doesn't matter right now. That's the process. That's the process for loading underway. And qtVlm can connect directly to you can connect directly to your Iridium account. You enter your username and password, and then you just log straight in to the satellite communications when you're connected. Or if you're using Starlink, you just turn it on and log in. And use it. Okay, so now let me demo this. What do I want to do? Command W. Okay, here. Okay, so I know. The main thing I wanted to say is this. Okay, so that's one way you can do it. You you can just go, and I've got other videos. This shows weather maps and satellite photos and everything else. Today we're talking just about ASCAT. So that's one way to do it. But if you're going to take a voyage, the quickest, the most efficient thing to do is just prepare your boat ahead of time and just load some of these into qtVlm so they're already there. Then you don't even have to go online to get the actual file. You can use the import. So if I go to import, then you see that defaults to received images. And here's what I've done. I've just copied these. These are small files, 300 bytes, right? These are just instructions on what to do. They're small bytes here. But I've just loaded them here. So now when I want to load any, I'm going to, let's say these are the 2 examples I was going to do, San Francisco and Biscay Bay in France. And so then you can just load them right into here. Okay, that way. So let's start out, let's just look at the index. I'm activating it. I've got the index. That's there. I've already loaded it. Okay, go. So now I do the index. So now I'm coming back here, and I think I've already mentioned this, but now San Francisco, we expect data at 5:35 UTC, but that's when it'll be valid, but I don't look until 7:35. And then if I get there right at 7:35, I'm going to get beautiful data to compare exactly with the 6 Zulu. Or likewise, I go at 20, 25, and take a look in this region. I'll download all four images, and I'll have a beautiful comparison, live, almost live comparison with the service analysis. And the service analysis legacy is about 2 hours, so maybe 2.5 hours. Or a little longer, maybe 3 hours. So it could be I get the ASCAT before I get the analysis, but then I can overlap them that way. If I look later, if I don't look at 20, but I wait till like 22, 24, then I'm going to get the same data. But I'm then comparing something that's 4 hours older. Okay, so that's the way it works. So now then, Command W. So then what you would do is start down this list. I want San Francisco B ascending. Let me look at that. Okay. I forgot to activate it. Not Command W. It's Option W. I want San Francisco B ascending, activate, and then OK. So here is the data, 457. Okay, so that's right. Remember, we're supposed to get data, plus or minus half an hour of 4 of 535, and that's certainly within that period. So this is the real wind data this is the real winds at that time. Now, I'm not going to be able to get to it right now, but then I can just overlay on here the GFS or some other European model or any kind of wind model I want. This close to shore, I could probably use the NAM or whatever. And then I could use this real data to investigate how well the model is, which I'm going to do the routing with. Now, we can actually route with this data, but that's another video to explain how to do that. And so the other thing is the way you read these wind speeds is this bar. It doesn't take much practice at all to get used to using this bar. You see the black is going to this light blue at 5 knots. We don't see any of that. The blue is going to green right at 15. So this line right along here is exactly 15 knots. See, this is darker over here. That's getting up here. The 20 to 30, going 20 to 30 is excuse me, not 20 to 30. Green to yellow is right at 20. So this light here is 20. So you see this is from 15 to 20, somewhere in this region. And so that's the way you get the wind speeds. And then if you zoom in, you can see the directions. You can see the directions there. So that's the wind. So this is now the first step. You see we got data at 4:57, and we were told that's when we're going to get it. Okay, command what? No, option W. I'm going to go back now to B descending. I'm looking at B ascending. Now look at B descending. Activate B descending. That's another one of the passes. And what do I get data here now? 1858 and 1717. And we were told 1825. So that's within that half hour. But again, you see, now it depends on what time I'm looking. I'm going to have, I know, again, to say what the principles are. I know that there's going to be data at 0535 and 1825. That's the times. Now, which one is closest to my real time depends on what time I'm looking. But I'm going to get data 4 times a day. 2 times a day. But I have to look at all 4 pictures, which take seconds like this, to see which one I'm actually getting at which times. So that's that. So that's that one. And then I'll do one more here. Command. Let's see here. And what do I got here? San Francisco. C. This is the other one. There's 4 that we have to look at. And this one is at 1815. 1815. Yeah, and it said 1858. So that's the way that works. And so this is the real data. I just did a summary here. I'm going to stop. I was going to also go to Biscay and do an example over there, but it's just the same. It's the same anywhere in the world. These indexes really work. And this is a way to organize and to use your data. Later, I'll make another video that shows how to compare this data. It's very simple. I download a model forecast in grib format and lay it right on top of it, and to be sure, okay, then I have to take the grib forecast model, which I can set to any time in the world I want to, within the forecast period, but I have to match it exactly. This would have to be 1815. So if I want to overlay a model onto this and compare the model's accuracy, this is the truth. What we're looking here in these pictures is the truth. And then to test the model, we have to set the model to exactly that time, or usually exactly that time. But then you're going to see things, and pretty soon I'll write up something explaining that. But there was some really interesting cases in the last Transpac race where there was kind of a hole that you could see. It's like this. This is kind of a hole here, right? These are the black real light air, and here's 5 or 10 knots of wind on all sides of this, but here's a hole. Now, sometimes, and here's the beauty of this, which one will learn, the more people play with this ASCAT, the more you'll learn the value of it. You can see this hole in the wind with ASCAT that won't necessarily show up at all on your best grib forecast. That's the thing that'd be nice to illustrate when I get to that next time. Anyway, that's what I want to say. I'm going to stop there. It's a wonderful thing to play with, and it will enhance the skill of your navigation using it.